Hello friends, hello everyone, thank you very much for joining me again. Today we continue our discussion on Spring Start. Here I have a copy. And we discuss about chapter 7, which is actually the first chapter of the second part of the book. We have just finished with the first part, the fundamentals, yoo-hoo! And we are now up to continue with a little bit more practical things. Not that that part 1 wasn't practical, but it was more with the basics. No, basics which I do remind you, if you don't know them by heart, I do recommend you go back and study it until you do, because a professional Spring developer knows those things very, very, very well. This is the reason why we have invested so much time in discussing about part 1. But now that we have finished with that, I'm going to share my screen, and we are about to finally proceed on chapter 7 and discuss about web applications. And from here we'll start discussing about the basic, still fundamentals, components, capabilities that you need to know, that all of them rely on the foundation we have discussed in part 1. So today we discuss about web applications, but at the same time we will introduce Spring Boot as a project in the Spring ecosystem, and Spring MVC, which stands from Model View Controller and defines the architecture we use for standard web applications implemented with Spring. We need to understand pretty well this design, because this is behind the scenes of most of our web applications. Everything that's non-reactive and implemented with Spring relies on Spring MVC. Be aware, regardless if we talk about a REST endpoints based application with JavaScript, React, Angular front-end, or a server side provided front-end, like for example using a framework like TimeLeaf or something different. All of them rely on Spring MVC, and that's why it's important to understand this design. Why Spring Boot? Why don't we go separately, like start with Spring MVC over Spring Vanilla, how we have used like everything in the first part of the book? Why do we get with Spring Boot starting from now on? Well, first of all, because it's time to do so. You are mature enough, if you have studied up and went through the book and understand pretty well the concepts that we have discussed in the first part, you can now step into Spring Boot. Secondly, we would lose time without gaining too much value out of it if we would go with learning how to configure Spring MVC over Spring. I have done that a lot of times. So I'm teaching Spring since it was like version 3 or something like that, maybe even earlier. And with those versions of Spring where we've used a lot of XML configuration files and stuff, and we had to configure the web application all step by step, which means everything, including the servlet container, including the relationship between the dispatcher servlet and all the resolver handler and everything. It took a lot of time to do that. So what you will see is that Spring Boot, this project, one of its biggest advantages is this convention over configuration, which means it pre-configures according to an agreed convention, an agreed by everyone convention, some of the things, which makes most of the configurations out of the box, including web applications, which spares you at least 30-40 minutes of doing that by your own in this case. So see, it didn't really make a lot of sense to teach you to do something that today we don't use anymore, and that's why we discuss this together with Spring Boot. So we discuss both of them, and I want you to be as much attentive as possible. I'm starting with the first part of the book, so let's discuss first about web applications. Of course, we will have many other chapters that follow, so we won't discuss everything in one chapter, you already know that, but we have a beginning here with what represents a web application, what you need to know for the very beginning about Spring MVC, web applications, non-reactive web applications, and Spring Boot as Spring ecosystem project. So web apps, why are they important? I'm gonna skip quickly over this section because we already know that today most of the things are no longer desktop based. You know by yourself as a user that today we use almost everything within a browser. No, so this nice nice drawing shows how things were when I was a child in the 90s. So we were using like different applications for everything, Winamp, whoever remembers that. And now today basically we use the browser for absolutely everything. Of course, we still have things that we do run as desktop applications, but the majority of the things today are somewhere in a cloud, and we do access them through web application, and you do remember that. Now let's see how this looks like on a diagram. Now this is the user. They have a front end and they access this front end in a browser somewhere now in this browser. So this manning application I'm looking at now, it has some nice things that makes things possible, makes this possible to see in the browser, including some actions, interaction with me. Like for example, it has this nice AI chat here, it has this nice search box here, the possibility for me to go on the left side, click a button and see the whole menu with the things that we are going to discuss today. All this interaction with the user in the browser is done through a front-end application. There are a lot of options here, a lot of frameworks, usually most of them JavaScript based, that we can use to implement this application. Now this application needs to centralize data and use some data processing, which is a little bit more heavy than what a client can support, and that's why there is a communication between what we call the client application, which is what we run in the browser, with a backend application, which is what runs somewhere in a cloud usually today, and which also has in a way or another some persistence, some database, some place where it stores data. So we don't discuss about the front-end part today because we are going to implement most of the things that we do implement with Spring are on the backend side, but we need to be aware of what part resides to the front end, and of course we will talk a lot about the backend in this chapter and in the following chapters, because what you do with Spring in general is backend applications, and this book focuses on backend applications especially because of that. So if we know how this looks like, and we know that we are going to see most of the things on the right side here in the backend rectangle from now on, and there is a communication, a request response communication between the client, so the browser, and some backend behind the scenes that provides with capabilities such as the data storage and manipulation. We can discuss further a little bit more about also how Spring MVC works with that. Oh, there is one more thing. So I see one more diagram here, which shows you that a front end is not necessarily only a browser. For example, it can be a mobile application, and of course one thing that developers need to be aware of is that usually, because you have more client instances running at the same time, you end up having multiple requests concurrently executing on the backend side, which means that what we need to do is always take care about the data that that is commonly used by this request. So Usually you should avoid having that, which means that we avoid concurrency, which means that each thread that will be created based upon a request will use its own data and preferably not have access to other threads' data. However, remember that in many cases, maybe most of the cases, the database will be a shared resources by these threads, and that's why somewhere in chapter, let me see, 12 probably here, or 13 actually, because 13 is about transactions, we'll discuss about isolation levels on the database for the transactions, and you learn that you can have different isolations, four levels of isolation that you can set up, and based on these levels of isolation, the consistency of the data is or may be affected. No, very important, however, up to the point where we will discuss that, to remember that you always have to think at a bigger picture, remembering that requests is not necessarily alone. A request in most of the cases is accompanied by other requests which run on different threads. So that's why this model is actually called a thread per request model. For every request you have a different thread. So going to section 7.1.2, no, we were actually, I was saying earlier that you have two different fashions in which you can implement a web application. So it's a fashion where the backend provides a fully prepared view to the client, which means all this, no, in response to a request, the response contains everything a browser needs to show the information to the user. Or you have a more complex scenario where you have a backend front-end separation, which means that a part of the logic, especially the logic related to the presentation and the interaction with the user, is moved to the front-end side, and then the front-end asynchronously makes requests to the backend, and that's how we can call it from now on a REST endpoint or a REST controller approach, which we will also discuss now, because in chapter 10 here, as you can see, we are discussing about REST services. So both we take both these approaches, and as you will see, behind this you have the same design. This design that's called Spring MVC lies behind both approaches. But in one of them, the first one, which usually is more comfortable when discussing about small applications, the browser simply receives everything it needs to show from the backend, while in the second one there is a little bit more responsibility usually given to the front end, and then the front end application becomes also a little bit more important in terms of the design, in the bigger picture of the system. So this is how you say a front end, a backend and the front end. When you do not have a separation, then you simply say just, hey, give me the product list and I need to display, and the server doesn't only give the product list, it gives everything like formatted HTML, CSS, JavaScript, all packed, so the browser will just interpret what it receives from the backend, and it doesn't process almost at all that content. It simply just processes, displays exactly what it receives. While in the other approach, the backend doesn't provide anything in terms of how the things are formatted and shown and so on and so forth. It simply returns usually a JSON formatted, or it's not necessarily to be a JSON, but it's a formatted way of the raw data. It's the raw data, and then the front end, it's the front end's responsibility to do whatever it wants with that data. So it simply the backend doesn't care anymore how the data is displayed. It can be like displayed like the raw data. It's the front-end responsibility who decides how the data is created. This is a lot more advantageous for more complex applications. First of all, because at the management of the work point of view, it allows for a better decoupling between the team developing the front end, so how the display for the user looks like, versus the team implementing the backend, so the processing of the data. And with a strongly defined contract here, you almost have no problems in independently deciding how to evolve on both sides. That's why in many cases today, backend front-end separation is always used, and it gives these advantages now. And most of the applications today, they are quite complex, which means in most of the cases this approach is helpful because it allows you to independently develop two separate responsibilities: how the data is presented and the interaction with the user, and how the data is stored and processed before it arrives to the application that presents it to the user. So we will take this, of course, step by step, and we discuss about both. So we discuss about this case, we discuss about this case, and they will both, being that they have the same design as we already have discussed behind the scenes, it's pretty easy because you will not have you don't have to learn two different things. Actually, you just have to learn the design, and you will see then that is a very small difference, a very small tweak in the design when jumping from the first one here to the second one here. So fortunately for us, Spring implements this in a way in which you don't have to like literally understand two different things. Okay, but let's go further and talk about the next thing. So regardless of what is the fashion in which you implement the application, whether you just serve the entire HTML, CSS, JavaScript, and you allow the browser just to interpret it, or you give more responsibility to the browser, you still have to okay, I'm gonna try to talk a little bit, maybe like that. It's a little bit better. No, thank you for making me aware about the voice. Let's talk about the servlet container, because regardless of the fashion in which you implement, you need a servlet container, which is this component that you can imagine it as a translator from HTTP to a Java method call. Let's just think very simplistically. You don't need like to dissect Tomcat or whatever servlet container you use. Now we have a few options like Tomcat, Jetty. Tomcat is the convention in Spring Boot, so you will hear about it most often. But regardless of the technology you choose, just imagine you have a translator from HTTP to a Java method call. For the very beginning, you don't need to know more than that about servlet containers. You rarely actually need to know more than that unless you have to debug things at the infrastructure level, which as a developer, in many cases, you don't need. So if you want to imagine the servlet container somehow, just imagine the servlet container as a translator. And someone at some point made me aware, they have asked, hey, shouldn't the servlet Tomcat container be part of the Spring app? Which is actually a very good point. Now I have taken this out in this diagram here just because I want the reader to focus on it, and if you think about the responsibilities, they are different responsibilities, but yes, normally it comes together with the Spring app. So maybe for the sake of the completeness of the diagram, we should have had one more rectangle here, and here we say Spring App logic, and then Spring App should be containing both of them. Okay, maybe I will do that when I'm writing the second edition of the book, but I'm mentioning that now just to avoid making you confused about that. So just now thinking about responsibilities, no HTTP request intercepted by the Tomcat servlet container translates this into a method, into a Java method call, and then the response of that method call is translated back into a HTTP response. So imagine Tomcat or whatever servlet container we discuss about as a translator between the HTTP protocol and the Java execution. Okay, that's why we need it. No, and here is a little bit more dissected diagram showing, you know, the HTTP request actually based on the configuration knows that when this request comes on a specific path, you can redirect it in the Tomcat to a specific class. This servlet is a Java class actually. Now it's intercepted here. Now, because servlets, so when web applications, not Spring, no, web applications started to exist, no, this concept of a servlet container and web applications, they are completely apart from Spring. Okay, you can implement servlets without Spring at all. You can just like write a class that extends a specific other class or implements an interface, configure it like into the servlet container, and then based on some configuration, but it takes, like as you imagine, it takes some time to make this configuration, the Tomcat will be able to intercept, like, and based on the path like /invoice here, redirect to one of the servlets, and you can have multiple servlets in the same container. So that's why it's actually called a servlet container. No, maybe you've wondered, why is Tomcat or Jetty, why are they called servlet containers? Why servlet and why container? Because the servlet is the Java component that can be triggered by the servlet container as a result to an HTTP request, and container because, well, you can have multiple servlets, and you can even have a configuration saying which path directs to which servlet of the many servlets you can put in the container. But as I will show you, when it comes to Spring MVC, the things are simplified a lot, because part of the redirecting functionality is taken by Spring itself. So normally this is how things would look like if you, let's say, don't have Spring at all. You can make this with Java Basic, have only classes registered in Tomcat, and then based on some configuration specify for a given path which of the servlets are called, and then Tomcat automatically knows first how to translate the request and then calls a given method in the servlet. That's what happens. Now when it comes with Spring, what happens is that you don't have so many servlets here. You actually have only one servlet, which is called the dispatcher servlet, because it does dispatches. So now from this architecture we are going to a Spring one, and in the Spring one we have the servlet, that one servlet that is part of Spring and registered in the servlet container. So you have only one servlet, and all the requests absolutely all the requests are sent to that servlet, which is called the dispatcher servlet. That servlet further knows how to dispatch the requests to the application, allowing us this way to move the configuration from Tomcat to the Spring application directly. So the advantage of this design, starting from here, where you should have configured Tomcat, you should have configured Tomcat in different means, usually XML configuration or whatever Tomcat supports now. No, to have multiple classes, multiple entry points, and to know to tell through Tomcat for a given path, for a given request, which of these classes is called, is triggered. Now you don't have that. Now you just have a Tomcat that knows to serve all the requests to only one servlet, the only one it contains, called the dispatcher servlet. And then that servlet, based on the Spring App configuration, which today we do with annotations, no? It knows how to go further and call a specific other class, which is what we call the controller. And that's how things start to link to what we know from the term, from the Spring terminology, no? Good, but before going further and see exactly, because I will come back then to also to these diagrams to explain a little bit more. But before we do that, let's take a step back and discuss about Spring Boot, because we have agreed at the beginning that we are going to use Spring Boot from now on. And the reason is, well, first of all, you anyway will use usually Spring Boot, not vanilla Spring, in your applications from now on. And secondly is because we would spend a lot of time learning how to do some stuff and doing some stuff, then that's not gonna help you immediately, and that's not like wise, no? So as I was telling you, I was telling you a story that when I was like teaching Spring many years ago, with the version of the time, it was probably Spring 3 or something, and we were using XMLs, and it's like when, I don't know, it's a lot different than we know it today. So if you are young enough, you might not know what I'm talking about now, but you can imagine it was not that easy. You had to do a lot of stuff and a lot of configurations just to put on standing a very small application. So when I was teaching this with Spring 3, I'm saying it even here in the paragraph, you had to like invest much time only in configuring a very small web application that does nothing. And this is something that today you do out of the box with Spring Boot, because Spring Boot, what does it do? It is one of the projects of the Spring ecosystem that based on the convention agreed by everyone. So it's a convention we know today in our community of Java and Spring developers what we use mostly. And Spring Boot configures that what the majority considers to be the best out of the box, still allowing you to change that configuration if you don't like it. So Spring Boot doesn't force you, for example, to use Tomcat, but it provides you out of the box with Tomcat configuration. You can still change it with something else, like with the means of some lines of code or some properties or both of them. You can change Tomcat to some other servlet container like Jetty, for example. And same with any other thing that Spring Boot configures automatically. You can change it. But it provides you out of the box with the convention. And that's what we call convention over configuration, meaning instead of forcing the developer to configure everything from scratch, Spring Boot provides you an auto configuration for the convention. You need to change it only if for your case the convention doesn't apply. It's possible, no, that the convention doesn't apply for everyone. That's why you have multiple possibilities. But it's a lot easier because statistically, in the majority of the cases, the convention usually, if it doesn't apply for a part of the application or for a capability and not for the whole application. And even if it doesn't apply, no, you can still change it, but it's easier to have all the other things already pre-configured. While in most of the cases today, we know that actually in the majority we do apply the convention, so we don't even need to make a change, in many cases. So you can easily create a Spring Boot project because it has that a Start Spring IO page, which is actually a web service and which is integrated with Eclipse, with IntelliJ, and with the majority of the IDEs, which means that it provides you a very simple, comfortable way to create a project. For those of you who don't know, you can from the majority of the IDEs, when you create a new project, you say I want a Spring Boot project, you choose some of the configurations here. No, I want the Java, I want to use Maven, I want to use Java 24 already. Yes, today was released actually, 24. I don't have a 24 now on my computer yet, so let's use a 21. The way I want it to be packed, and then automatically tell me ask me about what is the Spring Boot version I want to use, and then ask me about the versions, and that's it. And then when I click create, boof, it automatically creates. Well, in my case it opened on the other screen, but I will bring it here immediately. And yeah, point is, very easily, instantaneously, you have a project. And even more, all this project already comes with a lot of pre-configuration itself, because as I will tell you further, this pre-configuration is provided through the mechanisms behind the scenes in Spring Boot. So in my case, for example, for the simple fact that I've chosen that web dependency, which appears now here in my POM.xml file of my Maven project, only because of this, some multiple jars will be brought into my class path, and then a Tomcat will be automatically configured. The dispatcher servlet and all the other components from Spring MVC will be automatically configured as well. So all this stuff is automatically done because of this dependency here. And to create this whole structure, the only thing I needed to do is to click, and that's because of the Start Spring IO web service behind the scenes, which you can call from a browser as well if you want. That provides you with an archive based on your selections, and you don't even need to create all these files for your own. They just magically appear here, downloaded from a web service in the exact shape that you have requested it. This is fantastic, no? So let me go back to the book. So this is what it means here when saying a simplified project creation. And then what says dependency starters. Dependency starters, going back here, now if you read the name of this dependency, it says Spring Boot Starter Web. And for a big majority of the things that we will use throughout the rest of this book, you will see that we use these dependencies that contain the word starter. One down below here is the test starter. By the way, did I add this test starter anywhere? I don't think you have seen me adding a testing dependency, no? And this is another very important thing. I love this capability of Spring Boot. providing you out of the box with the testing dependencies without even asking you if you need them. You know why? Because you always need them. By convention, you have to write unit and integration tests. Unit and integration tests are extremely important, and any verse developer knows that there shouldn't be any case, there shouldn't be any project where you don't write tests, proper tests for your applications. So that's why Spring Boot considers this a convention. It didn't ask you if you need tests. Out of the box, it provided you with the tests because you need them. Okay? So this starter, it's actually a pack of dependencies that are also curated to be to have the versions compatible with one with the other. So you see, very important thing here, it does come with a version. Maybe you have observed that. Maybe you know from the previous discussions, from the previous chapters of this book and our discussions here on YouTube, that you usually have also a version here, no? You remember? I had a version here. But here you don't have a version. We don't use a version tag. The reason is the version is actually provided through this parent here. What is this parent? This parent is a parent POM. No, POM stands from Project Object Model. Object model. No, it's like classes in Java. They inherit one, they can inherit one another, so they rely, all this model relies on inheritance and dependency. Now has a relationships, which are the dependencies. These are the has a relationships, and is a relationships, which is the inheritance, which is the parent here. So you have a parent, and the parent comes with a lot of the things itself. So here the versions don't need to be specified because they are provided through the means of the parent. When I have added here, when I have actually selected, no, because I didn't add it by hand there, but when I have selected in the very beginning, I want to use versions 3.4.3 of Spring Boot, what happened actually is that this parent has been used here with the proper version, and then the dependencies here will use the exact versions mentioned by my parent, which I know they have been tested, they are compatible one with one another, and I can properly use them. I don't have to manually search and add my dependencies here in the dependencies. Think about what I need. I'm just telling Spring Boot, hey, I need to create a web application, and it automatically brings me all the dependencies I need for a web application. Isn't this fantastic? So are the version of these dependencies set according to Spring Boot version chosen? Yes, exactly as I was explaining. So is according to, basically they are coming from the parent. They are that's where they are specified actually. And this is not actually only one dependency, no. The starter is like a starter pack. That's called the starter. It's a starter pack. It comes with all the dependencies compatible with one another. They just are. You can look in the external library. So I only have two dependencies. Now, if you put them like that, but in reality, it's a lot of stuff coming here out of the box, which is everything that I need, including the embedded Tomcat and everything that I need, logging, the Jackson, for transforming the object, mapping the object to JSON and so on, everything I need to create a web application. And say they have POM inside parent, which will make sure all are compatible. Yes, exactly as I was explaining, exactly as I was saying that. Good. Going back, third point here that I'm going to discuss, no? So auto configuration based on dependencies. Now, based on the fact that I have some things in the class path, automatically some things will be out of the box configured. Now, what it comes out of the box is also the structure of this project, which you need to understand. But besides the structure of the project, you have to always remember that this will always come with a lot of pre-configuration, which mostly relies on the dependencies that you add to the project. So for example, now when I'm running this, even though I didn't write a line of code, you didn't see me writing a line of code, no? You can take a look and you will see it's only some default stuff that we can discuss, but I didn't write a line of code. And even though I didn't write a line of code, automatically a Tomcat instance will start, will open port 8080. Why 8080? Because that's the convention. Yeah. Can I change the port 8080 to something else? Yes, I can. No. And I can even send requests to this. And that's extraordinary, no? Because I didn't do anything. I have just created the project by specifying some technologies and everything and downloaded it. And probably I have some constraints on my computer here. And this, yeah, started. Ah, no, I've run the tests. Apologize for that. So I was running the tests. I wanted to run the application. No. I'm also running from a notebook that has some restrictions, so I don't know exactly if I'm able to open any port and stuff like that, but it doesn't really matter. No, you can take me for granted. Yes, it did in the end. Okay, you can see it opened port 8080. So my application started. This is a whole web application, and every time I'm running such an application like this, I appreciate it a lot, because I remember how it was years ago when I had to configure myself a lot of stuff, and it took me like more than 30 minutes to put in place everything to really have something like that. And now I made it out of the box. I've only downloaded the project and it works. I didn't have to configure any servlet, any dispatcher servlet, any Tomcat, any configuration of any kind, and it works. This is extraordinary. But at the same time, no, I didn't want to start the book with this, because this is a lot of magic here. And when we will start working on the application, if you didn't know any Spring, and I would bring you directly to Spring Boot, you might have felt there are a lot of holes there. Now you will basically, if you have followed with me the part 1 of the book, you will understand a lot better what happens when we will write code, specifically code there. So how can I see the respective auto configuration started? Do I need to know which exist? Well, that's a good question, because it's quite difficult now to know exactly to follow the auto configuration. One of the ways is to extend to debug the logging level, and then you will see basically everything that is auto configured. But what happens there, what is actually doing the pre-configuration, is you see this main method has automatically been generated for me, same as the whole structure of the project. And then based on this is starting the things and knows how to parse first of all my project, and secondly the class path, and based on that to decide what it configures and not for me. Now for the majority of the cases you will know what is pre-configured, because well, when working with technology, whether it's Spring MVC, Spring Data, something related to messaging and Kafka or so on, you will have to know something about what you are doing. You will not just gonna blindly just work and expect that some things work and some not. No, you will have some expectations, you will have some pre-knowledge. Now if you want to debug that, then what you can do is changing the debug level, and then you will have a lot of messages. But then that's something that we should discuss separately, I know, maybe in the troubleshooting playlist, because it's a lot of things a lot of, let's say, techniques to apply when you are searching for something specific. You need to know what you are searching for. You can't just assume I'm enabling the logs and then I can follow each line, because there will be a lot of log lines generated. So you need to search something when you do that. You need to know what's your objective. Yeah, going back, no, so we discussed about the service creation, so I'm gonna fast now go, because whatever I told you and I've showed you now with IntelliJ is described step by step in the book, which is of course something nice, because when you open the book you have everything in place. So I have already shown you how you use Spring Initializer, and I have shown you how, yeah, we didn't use directly start Spring IO. We have used the ID directly for me, but you could have actually went in the browser here in the address bar, start Spring IO and fill in the same data, download the archive, and then open the archive in the IDE, whatever your IDE is. See, at the same here, you see how the page looks like. This is how start Spring IO looks like. It might be now a little bit different. Sometimes they change the style. This book was released like, I don't know, 4 years ago, but it works the same, I promise. You see, and you select everything you need, like if you want Maven, what kind of Java you want, what are the dependencies, and then boom, 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 boom. It explains you the structure, and that's it. Now you run it, and then you have a web application out of the box. No. Now, all this thing, it also explains you the structure of the Spring Boot, and I would like to discuss the structure of the Spring Boot together with you as well, the Spring Boot project, sorry, together with you. So you see, I did put all this in order to see all the files. So the most important for you are the following. So you have the source folder, which contains 2 subfolders, the main and the test. The main is where the application goes. The test is where the unit and integration tests go. So the testing part will be in the test. The application part will be in main. It's quite simple. No, so in test, very easy. It created for you a test file automatically. It's empty. That's where it invites you. No, Spring Boot invites you to continue starting writing your tests from here. We are not going to write unit tests today. We are going to discuss about unit and integration tests here in chapter 15. So at the very end, not because they are not very important, but because first, before testing something, I want to make sure that you know properly how to implement that something. No, so that's why I left tests at the very end. And then of course you have the POM XML file, where we have discussed that you have the parent. The parent comes with the BOM and everything, so you know that what comes implemented is that's the reason why we don't specify a version here, and why in most of the cases the versions are the ones agreed with the parent. No. And I have also discussed about why we have also the testing dependency here. One more thing might be interesting to be mentioned. Also, this plugin is very important. You will always see this Spring Boot Maven plugin. This is part of what creates the pre-configuration, because remember that some things can be configured at runtime, so that's when the application starts, but there are things that need to be configured at another stage of building the application, and the only way to do that is using a plugin in your build tool. So this plugin is part of Spring Boot and is essential for Spring Boot to be working. You will rarely do things like excluding things from here or workarounds. I don't discuss about them here because for this book they are unrelated. I can consider them more complex things, but remember, this is also an essential part of what creates the magic behind Spring Boot. And then of course we have the main folder here, which is split itself into two. We have the resources, which will contain sometimes static data or templates that we usually will use with web applications. You will see them probably in the next discussion. The properties files, which usually are written either as properties properties format or YAML format. So YAML and properties, they are both supported by Spring Boot. It's not one better than the other. It's a debate. If you'll hear developers, some of them hate YAML, so they choose properties. Other they say, hey, properties now can become very long in names, so it's easier to put them on vertical if you have a YAML file now. So imagine you have a YAML file, application YAML, then the same thing, Spring application name would be Spring application name, name, and the value. No, so instead of having it like this, you have it like this, which helps you spare some space on the horizontal, because sometimes you have, I don't know, blah 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 blah, it's very long and then difficult to read. No, and of course you also, if you have a properties, I have a Spring application and something else here, for example group. No, you have to write Spring application twice, Spring application name, Spring application group. Here you would say just, I'm going down below and add the group. So it has, no, both of them have advantages or disadvantages, but it's not that essential. No, you can now choose whichever you want of these formats you like. If you like the YAML format, choose the YAML. If you have the properties, choose the properties. They offer you the same things. It's just a matter of how you write them. If you like one more than the other, it's your choice. And then we have the Java part, which comes with a main package, which is the package in which the main class is also created. I want you to remember this main package. In most of the cases, what you will write should be inside the main package. I will tell you next time why one of the most common issues for beginners with Spring Boot is to create things outside of the main package like that. Controllers. No, at the same level. No, controllers should be inside the main package like that. Next time I will show you what happens if you don't do that. Okay? And besides this main method, which basically starts the application, starts the creation of the Spring context and everything we were doing in the first part. Now you remember, you will also have some definition here with some, say, configuration done here with this Spring Boot application, which always is over the main class. And I will tell you next time, we don't have to understand everything here, but next time you will understand that this is the place where some component scanning in the main package is decided, some enabling of the auto configuration is decided, and some of the, let's say, things that with Spring Vanilla you would have done manually, they are coming from the Spring Boot application itself. No, I will also tell you that this Spring Boot application defines the class as a configuration class, but I will also tell you next time why you shouldn't actually use it as a configuration class in general, only in examples. So so that's basically it. Now I don't have more time, so we stopped here and we still have to discuss about maybe a little bit more about the convention and everything, but I think we have actually discussed about this, so we went through all this. But we will actually start creating our first web application next time. So I'm gonna end the things here, and next time we'll probably start with creating a very small Spring MVC by the book, explain it, and then we can even jump into chapter 8 probably and make a comparison with what REST is and everything. So without keeping you too much here, and because the time is over, I'm very happy again you've been here with me. Thank you very much, and hope to see you next time to discuss chapter 8 and the next important sections of this book Spring Start here, which is right here with me. Thank you very much, everyone. Have a great time.